1-4, composition of functions. At the end of this section, we should be able to answer these questions. First, what is a composite function? What is the notation for a composite function? How do we determine the domain and range of a composite function if the original functions have limited domains and ranges? And finally, what is the distinction between domains and ranges? Okay, let's start with a quick review of how we work with composite functions. We'll start with these two functions, f of x equaling 2 to the x and g of x equaling the square root of x. And we're going to try and find f of g of 3, g of f of 3, and f of f of 3. So for f of g of 3, we're going to take the 3, the very inside value, and plug it into the next piece of information, g. So we plug 3 into g, and we get the square root of 3. G of 3 is the square root of 3. Now we're going to take that answer and plug it into f. So what I'm really looking for is f of the square root of 3, which would be 2 to the square root of 3. Calculator, that's 4, 2 raised to the square root of 3. Enter. We have 3.322 rounded to 3 decimal places. There it is. Now, we're trying to find g of f of 3. Then we plug 3 into f first. So we first find f of 3, which would be 2 to the third power, which is 8. And then we take that answer and find g of 8. So the square root of 8. The two-step process. Plug into the inside function, and take your answer and plug it to the outside function. So you're looking at the square root of 8. We have 2.828. There it is. Now, f of f of 3 means we start by plugging 3 into f. So f of 3 inside is 2 cubed, which we got out was 8. And then we take the 8 and plug it back into f. So f of 8 is 2. 2 to the 8. For our calculators, 2 raised to the 8. We get 256. Bingo. Now, we want an algebraic equation that expresses f of g of x explicitly. So we use the same process, but instead of using a number, we're going to use x. So the first thing we do is we plug x into g, which we've already done. So g of x being the square root of x. And then we take that expression, the square root of x, and we plug it into f. So f of g of x, we take that square root of x and replace x with that expression. So 2 to the square root of x. There we have it. Okay, so let's take a look at another problem evaluating composite functions. Only this time, each of our original functions are going to have limited domains. And this time, we're going to let our calculators do the work for us. So we're going to try and find these three values, f of g of 5, f of g of 8, and f of g of 2, using these two functions, f of x equals negative 2x plus 8, between 1 and 5 implicit, and g of x equals x minus 3, for x is between 2 and 7. So the first thing we need to do is get these two equations into our calculator. I've already done that, as you can see. So the first equation of y1 is f, and I've added the Boolean variables to incorporate the restrictions, the limited domain. G of x I placed in 1 and 2. Now, the function that we are actually trying to evaluate is f of g of x. So here, I'm going to take advantage of the function notation, and in y3, I'm going to ask for y1 y2. See, bars, y bars, y2. So now if I go back to my home screen, I should be able to plug in or ask for y3 of these three values, 5, 8, and 2. So let's start with 5. I'll plug 5 in. Home screen. Bars. Y3 of 5. Well, we get the answer. Let's see what we know it will be. If I plug 5 into g of x, I should get 5 minus 3 is 2. And then plug 2 into f of x. Negative 2 times 2 plus 8 would be negative 4 plus 8. So it should be 4. We get 4. Okay, now let's try for f of g of 8. Ask me f of g of 8. Recall my last entry by hitting second enter. And then I can edit that. I'm going to ask for y of 8. Now, we go through the same process. I'll plug 8 into g of x. 8 minus 3 is 5. Plug 5 into f of x. Negative 2 times 5 is negative 10 plus 8. So I should get negative 2, right? So let's find out. We'll hit enter. Whoa, what's this? Divide by 0. Alright. Let's click and see if we can figure out why that happened. Right there. Well, if we go back to our equations, we'll notice that our starting value of 8 is actually outside the restrictions in Gx. So when we try to plug that in, our calculator warns us that our Boolean variable has a value of 0. It's false. And in that case, we divide by 0. So when we ask for f of g of 8, we should say does not exist. If I ask you why, then we would explain that 8 is outside the domain of G. Alright, well let's try f of g of 2. 2 is definitely inside the domain of G. And it also is between 1 and 5, so we shouldn't have a problem. Let's ask for f of g of 2. So we'll call back our last command, replace the 8 with the 2, and see what happens. We get the same error. Why does that happen? We certainly can plug 2 into G. There's no restriction there, or we meet the restrictions. So when we plug 2 in, we get g of 2 is equal to negative 1. Now this value is what we are plugging into f of x. But if we check the domain restrictions for f of x, we see that negative 1 is not between 1 and 5. So again, f of g of 2 does not exist. Our explanation, if we should be asked why, would be that g of 2, or negative 1, is outside the domain of our outside function, or f of x. So while we were able to get started in evaluating this particular question, our process breaks down in the middle during our second step because of domain restrictions. When we looked at f of g of 8, our process broke down immediately because of the domain restrictions on the inside function.